All right, hello everybody. This is the Nephio SIG Automation call for October 5th. Let me bring up the agenda. All right. Okay, great. Well, thank you everybody. Cal.
Yeah, good morning. Apology in advance, I'm feeling a bit under the weather today. I got my COVID booster shot, and it's reminding me that it exists in my body. So really, I think the session today will be entirely about talking about components. Myself and John both submitted proposals, so we can go over those. And otherwise, I wanted to start by mentioning something we talked among the chairs. How does everybody feel about moving to a weekly cadence for our meetings? Or rather, are there any objections to that, and why?
I think it makes sense. The phase that we are in right now and the about aggressive goals that we have totally makes sense to move to the weekly cadence.
Okay. I guess that's we're gonna, and I assume it would just be the same time.
Right.
Does that work? All right. Awesome. Okay. Thank you.
Alok, please.
Yeah, hi everyone. This is the first time I joined the SIG Automation call, but I've been following passively the recordings as well as in the Slack channel. Regarding moving to the weekly cadence, I think it's a good idea, but just a disclaimer, we have a ORAN conflicting call at like last 30 minutes. So, and I see some of the attendees here are also joining that call as well. And is it possible now, if we are moving into weekly cadence, to prepone by 30 minutes and then we can take both the calls? Just a proposal.
Yeah, it is possible, but of course, every kind of change like this will involve something. We are looking into using some sort of online scheduling tool to help us see majorities. Yeah, already we're getting -1s, right? So it's a huge problem. Yeah, I don't know quite what to say. One thing we do here at Nephio is that everything is recorded, right? So there's always it'll be on YouTube. That's not something that ORAN does. So so you have the advantage here of you're not going to necessarily miss out. So I don't know. I think we can open it up again. Definitely, if we're rescheduling to weekly, it's worth asking everybody again about the time. So I think as soon as we get our calendar scheduling tool set up, then we can ask people again how they feel about the time. What do you think, John?
Yeah, that would be okay. I think.
Yeah. Okay. An, please.
Hi, I'm looking at my the ORAN schedule, and basically from 5 a.m. Pacific to 9 a.m. Pacific is ORAN security, ORAN, energy saving, joint working group, common app LCM, and then the working group 6 Greenfield accelerated abstraction layer API ecosystem, and then the Nephio, and overlapping that with IMS provisioning. So O2 O2 infrastructure management service provisioning call from 9:30 to 11.
Well, you know, ORAN has many work groups, right?
I know.
Yeah.
And so I think it will be next to impossible to find a slot on Wednesday, to support support both sides of the house.
Right. I mean, there's an option also of moving another day, but
Yeah,
I'm so worried about this because it's so hard to find a time that kind of worked for the people here. If we move it to another day or another time slot.
Yeah. I agree.
However, on the other side, ORAN is definitely an important mix. But if it's our liaison and cooperation with ORAN, if there are moments when that's very important, we can set up even special meetings for that. And of course, there's SIG architecture too. I mean, the SIG automation is important, but it's not the only way for the two projects to coordinate. There's the TSC meeting as well for Nephio. It's not the end of the world if there's a conflict sometime, in my opinion. It's inevitable.
Yeah, I mean, I've been juggling both meeting the IMS
Yeah.
provisioning and this for weeks now. So
Yeah,
but what?
yeah. Go ahead. On was there something else?
Yeah, one point I want to raise. You mentioned liaison. Maybe we can have. It's a suggestion. Maybe we can have designated liaison between the two groups who can make sure that the connection happens, the information flow instead of just relying on
Right.
people.
Yeah. This was mentioned in the workshop too, and I have a feeling that's something for the TSC to decide if there's a formal kind of. It's like sending an ambassador, right?
Yeah, there's actually, unless I'm in at least in one of the drafts of the TSC's operating documents, there was specifically a role defined for that sort of thing. I don't recall what ended up. I would have to go back and look, but that would be. Let's talk. Let's maybe, and if you have time, you could take a look at those documents, which I think have been ratified by the TSC and are on the GitHub or on the Drive or somewhere. And I think there's a role like that, and we might have to raise a something for the next TSC meeting to nominate or whatever, somebody for that.
Yeah, here's my suggestion. Let's move on for the agenda. I feel like that's important, but I think it might be better set up as a separate agenda item, maybe for the TSC meeting. We have a lot to do today, so if that's okay with everybody. But yeah, we have more people with hands. Is it related to this topic? We'll go ahead, please. Ravi?
Yeah, no, just on that, on the overlapping with the ORAN meeting. So the one that's good, because we are planning to do this on a weekly basis, and there's the other meeting is it's directly related to cloud infra management and so on. So I mean, there's that. I mean, it's a very relevant topic to this group too. So if it's okay, I would kind of at least request to consider Thursday the same slot. Then at least from the other working group 6 perspective, I don't think there's an overlap.
I think that's exactly what
the TSC, right? I'm sorry. Yeah.
Pardon me?
That's exactly when the TSC meeting is.
Yeah, Thursday same time would be TSC meeting on the other week. Yeah.
Oh, okay. Or on that at 10 o'clock. I mean, if we can push it, after that. So
that's tough for the European folks, right? So this is where it gets super complicated, super fast.
Okay.
Yeah, it's impossible to satisfy all the cases. Like Tal said, let's move on to the main agenda items. Yeah.
Or think about 8:30 to 9:30. I think that should be fine. Anyways.
I mean, we could definitely do a poll and see if it works. I think this, of all the considerations, the ORAN overlap is the most important, I think. So let's try and see what the community as a whole thinks, right? We have 33 people on the meeting today. So we'll see we'll try to get a poll from everybody and see if that could potentially work. Jean-Marie?
Yes, that's on the question of license. We need to be careful. If we are setting up license, then we need to have a formal process of agreement and approving what are.
Right. That's why I think it should be a TSC and not for SIG Automation.
Well, we need a process within SIG Automation and then ratification for TSC before we have a license that is sent to a formally established, to a de jure established group. So that's something that we need to keep in mind.
Yeah, it could be that it's too early to create a liaison because we don't have an exact idea for the role.
Well, and liaisons are speaking officially on behalf of the entity that they are liaising from. So that's becoming an official statement of this is what the Nephio communities, what the Nephio community thinks.
Yeah, so let's table it because we need to check the operating documents. I think they actually already have this concept in it, and then we'll have to figure out. There's probably some procedure in there for how those people get selected. So there is a role, as I recall, defined for that.
Yeah.
Or they stripped it out, in which case then it's another topic, and then we have to readdress it. But
yeah, but I would suggest adding it right now to the TSC agenda for next TSC meeting to consider that.
Is that okay with you, Anne? I'm putting you on that thing here.
Yes, please. I mean, I was thinking more of expediting the interaction, but you know, we must follow operating procedure.
Okay.
So I think it's a good idea to move to the main topic today. It's a very important one. Starting to get into a draft of Nephio components. So one of us can go first, John, whoever you wish. The interesting thing I'll note immediately is there are two very different approaches to the problem that John and I sent, but you know, we do not represent the community as a whole either. So it doesn't mean that there's a split 50% exactly, but I think there's a lot of alignment too, and I think it'll be interesting to at least look at this from two different perspectives. So John, what do you think? Should I go first, or would you prefer to go first?
If you want to go, that's fine.
Okay, so I could, your screen is already shared. If you want to just click the Google Drive folder. So I thought to start actually with the first document, which is a reference, and I'll go over this very, very briefly. We're not going to dive into this a lot, but this diagram was prepared by my colleague Alexei. He can't make it today, but he, you know, he was thinking about this problem too of, you know, what would be the components, and he thought, well, let's start looking at Red Hat, what components we actually have. And let me tell you that this diagram, which is already complicated, is partial. There's a link at the bottom right for others, and there's a lot there and a lot more coming into the pipeline. And the reason I think this slide is important is these are the kinds of environments in which Nephio would operate, right? There's a lot of stuff there already, and there are different approaches to it, right? The Red Hat approach is a very Unix philosophy, very much about there's a specific issue, create an operator for that. And some of these operators are upstream. There are things like Cert Manager. There's things like Kyverno, which is a policy enforcer. But then we have all these hardware specific operators as well. So, and you'll notice also this is workload cluster heavy in the diagram. Most everything happens in the workload cluster. And this is where I think Nephio is interesting coming in when we're starting to think about, well, what do we do in the management cluster to make this happen, right? But again, I encourage you, if whoever is interested, go over this slide yourself, click on the various links if you want to learn more and try to understand, you know, what one company is doing in terms of trying to solve the infrastructure management and connectivity issues with CNFs, right? So I won't go over this more again, but I think it's very interesting. And if anybody has specific questions about delving in deeper, then you can contact myself or anybody else from Red Hat who's involved in Nephio. We swim in this every day, so we're very familiar with it. So with that, I'll go to the next document, which is actually the, you can probably click your back button, or yeah, the component landscape, right. So what did I try to do here? This is somewhat simplifying top view of the main components we can expect to work with, and where Nephio would, I imagine, fit in and fill in some gaps that we have. So first of all, the colors here, orange is kind of the brownfield, if you want. It's most of what the platforms already supply. So this includes everything we saw in the previous slide, right? So again, taking into consideration that you're moving into an environment where there already is a lot of work done, and Nephio does not want to reinvent the wheels, right? It wants to glue them together into a coherent narrative. So the orange ones are the things that I'm assuming are already there. And I'll note already that there's maybe, this is one point of disagreement between myself and John's proposals, where I'm assuming that the CI, CD, GitOps, etc. pipeline, which is the thing that takes the CNF blueprints from some sort of repository, it could be GitOps, it could be something else, and moves them into the Kubernetes world. I'm assuming that these things already exist. It could be KPT, it could be other things, right? There's Argo is used in Red Hat. Flux is very popular. Yeah, we can talk about how, I think we're going to talk about that later when John presents his version, where for John, I know for you, KPT is a required component of Nephio, right? So we'll talk about that, right? So for me, it's orange. I think for John, it might be blue. So blue is where I think the gaps that Nephio can fill in. And I'll mention also that these parallelograms that I chose them because I don't intend them to be one operator, right? This is a higher level component view. Each component itself can be composed of maybe several operators that work together, or not necessarily even operators. It could be other subsystems that work externally to Kubernetes or on top of Kubernetes, right? Because again, we're dealing sometimes with components that might not be as cloud native as we want them to be. For example, policy frameworks that exist out there, say in ONAP, right, that are not necessarily designed to work in a management cluster and in this environment. So with that said, I'll just zero in on where I think Nephio could fit in here. So the first central component in the management cluster is something that I'm going to demo next meeting, a POC that I'm working on called Planter. You can click on the link there if you want to learn more about it, but I call it the bifurcated scheduler, right? The idea is that we signed the demo last meeting about, we saw that problem of bifurcation very directly, right? We saw KPT moving towards infrastructure resources and then also to the workload resources. And in GitOps, you also have that kind of separation, right? They're here and there. My idea with Planter is that the bifurcated problem exists, but just like in Kubernetes, the LCM problem exists, but a declarative environment hides those implementation details away. We're aiming for 100% declarative environment where you can declare all the CNF requirements together, all the specifications, whether it's workload or infrastructure. And you shouldn't care about what needs to be done when, right? That should be an implementation detail, and that detail can change also according to the complexity of your resources, including custom resources that have nothing to do with what Nephio defines. So the idea with this bifurcated schedule is that it's a higher level scheduler that takes care of that for you. It does two things. It sorts. So first of all, it figures out which resources go into which clusters. And this is also addressing the multi-cluster use case example, where you might have multiple workload clusters and they might have different management clusters that they need to work with as well. So the sorter would make sure what goes where, but it also does sequencing, which might be a higher level version of scheduling, because as we know, and John, you discussed this too, and some changes that you're making, that, well, the workload cluster might not exist yet, right? Until it's actually installed, we can't put things there yet. So Planter would be able to wait, right? And wait until that cluster is on in order to move the resources there. Yes, Jean-Marie, please.
Yes. What difference are you making between schedule sequencing and dependency management? And in particular, the resources that you are waiting on the workload cluster wouldn't they be modeled into the management cluster, and therefore it's back to just the normal reconciliation loop of the operator pattern, and there is no need to wait and sequence anything, because in a cloud environment, any resource can go away and will come back.
Sure, of course, but So if you click on the link, we'll talk about it when I actually demo it more. But I'll say briefly, yeah, one of the phases is sorting out the dependencies, and specifically, there's a difference between soft dependencies and hard dependencies. Soft dependencies, Kubernetes already takes care of them. If you create a service and a pod, and the pod goes away, or the service goes away, or the pod doesn't exist yet, that's fine. Everything will eventually work when the components work. But we also have hard dependencies. For example, the fact that a cluster might not exist yet. But also in Kubernetes, you cannot create a custom resource before the CRD. You cannot create your resources in a namespace before you created the namespace. There are some hard dependencies, so it will try to figure out only the hard dependencies and sequence that. But yeah, anyway, we can get into that next time when I go into Planter. I want to talk about the other components a bit. So the 4 big blue ones. Yes, Ben, please.
Yeah, so I just wanted to clarify. So you're right, is that there are a few dependencies like CRDs and namespaces and stuff like that. But if you go, if you take kept as an example, it has that built in.
Right.
So it has that.
Right.
So that's
yeah.
And that's for me a bit of a difference between using traditional Argo and Flux versus kept, because in kept you have already because these dependencies of namespace and CRDs is an explicit one that we have to deal with when you schedule the resources, right? But you will find most of them are soft dependencies. For me, a cluster not being there or being there should be taken care of by the controller that does it. For me, a cluster is similar to a pod, or similar to a node that exists or not.
Yeah.
Whereas the hard dependency between namespace and CRDs we have. But in my view, if you take an approach like kept, it basically it's built in there. It has that hard line that it can take care of.
Right. So I did a quick live fix to put this component with a 2-way arrow with a CI/CD pipeline. Yeah. So again, we don't want to reinvent any wheels, right? So if we already have a system to handle sequencing, that should be done. But we still need, I think, a component to sort things out. You'll notice that the Planter, I have this idea that it has to contact the site inventory and know what's there right now, right? The CI/CD pipeline. But anyway, I don't want to.
Yeah, let's not get too into Planter. Yeah, I agree, Vim. I think that and I'll talk afterward on mine. And like Tal said, my blue box extends up further, but actually just blue boxes that are here well, we'll get to it. Go ahead, finish up, Tal. Well, right, Ravi's back, yes.
Yeah, Ravi, would you like to make a point?
No, yeah. So my question was primarily on this color coding because it says blue for Nephio, but I see all other components like you have the cluster management, CI/CD, policy for config sync. I mean, these are very much within the scope of Nephio too. So you can clarify that. And my other question was that is this an implementation architecture or the Nephio architecture, and how are we tying it something that might come out of the SIG architecture?
Yeah, I see this as implementation entirely. So whatever the actual there's no idea here of how I mean, obviously this is architecture too, right? But this is slightly lower level, I think, than what SIG architecture would deal with.
Well, right? So there's a reason it's SIG network architecture. It's not called SIG architecture, and the reason is that it's intended to be about the network architectures, about what the heck is a 5G core, what is RAN, what are these telco networks, how are they constructed, what's the information model for them. The platform or software architecture of Nephio is within the domain of this SIG, not that SIG. That's primarily populated intentionally by people who are not necessarily software engineers, but are network engineers and network architects and network designers. And we need both of these domains in order to make a successful project. So originally we had SIG platform for this intention, to be clear that the platform software architecture is different than the network architectures, the networks that this software will be used to construct and manage.
Yeah, no, that's what I was also, because we have this link that comes from the service orchestrator, which is supposed to be open API. So I was just trying to understand, why is it terminating at the resource network optimizer, and so on. So yeah, so we need to correlate that. Otherwise,
let's let Tal finish his presentation. I mean,
yeah, sure.
I think we'll all have, like you said, I have a slightly different view of these things, and I'm sure everybody on this call has a slightly different view of all of these things.
Exactly.
So we'll figure it out.
The truth might be somewhere in the middle. So thank you for this feedback. Yeah, the point I want to make about the last point about this planter and the resources that are involved here. So it's sorting them, it's figuring out the dependencies. It's actually a very simple component. In general, I imagine that most Nephio components will be really simple, straightforward, lightweight things. They're kind of connecting between things that already exist, which, again, if you look at the previous slide that I showed of, if you will, John, so what the planter will, the resources that the planter sort will go into this ecosystem that already exists there. So probably a lot of custom resources that will deal with very specific things that are solved already for, if it's a DPU driver operator, if it's SRIOV, if it's PTP. The list there is very, very long in terms of the networking and infrastructure connectivity resources that could come out of there. So Planter doesn't necessarily know about what they actually do, and it doesn't care. It doesn't handle the actual reconciliation of those resources and only sorts them out. But as I'll show in my POC, I'm thinking of it as something extensible, that it will be easy to write little Python scripts, for example, to sort out your own custom resources if you need to. So because there will be a lot of custom stuff. So I do want to move to the other components. So looking at the management cluster still, so here's a component where I think we're really missing too. And right now, if you look at some orchestrators that try to address the telco space, thinking about multi-clusters, very large deployments, they have some opinion about how to connect clusters in the first place, or they assume that the clusters are already connected. And there's a chicken and egg problem here that keeps repeating itself. And we know there's very interesting projects that try to address the inter-cluster connectivity. All of them go about it in a slightly different way, right? Some of you are familiar with Submariner and Scupper. Those are official CNCF projects. I think there are more in the CNCF, but there are also all these other products and other approaches there. And some of them involve systems that are external to Kubernetes entirely, right? Because the connectivity between sites, in a way, is not in the domain specifically of Kubernetes. So in my idea, we have to have some way to express these kinds of requirements for connections within Nephio. This is probably the most vaguest component in my mind. I don't know exactly how this would look, and I have never created a C on this.
Yeah, if I can just interject, so I see this as transport. Like this is out of scope in V1.
Yeah, it very well could be. This is probably the as I said, it's the most vague one.
Yeah.
But it's a gap that we're constantly hitting against, right? When we're dealing with any kind of solution that involves, because here's the thing, Nephio assumes management clusters and workload clusters separate. So it already assumes at least 2 clusters for any use case. And we need to talk about how they even connect to each other. So yeah, it could be a future version, but you'll notice I draw a line down, and I want to talk about that line going down from it, the arrow, where it has to be, if we're doing multi-cluster connectivity, it has to speak somewhat to the inner cluster multis connectivity. And that's a very, very big one. I mentioned before that I try to create a CNCF work group on this topic of how do we manage multis networks at scale. This is a huge gap. I have a few presentations on the topic. I'm mentioning a POC that I made called KNAP, but there's NM State, which is not a replacement, but addresses the problem too. But we have a huge problem where, I'll put it very simply, if you want to package a CNF with some multis networks, so you have to create the network attachment definition custom resource, right? But these are CNI configurations in JSON put into a Kubernetes custom resource. How do you write those CNI configs if you don't even know which workload cluster will be deployed on and which node it will be deployed on in some cases? Because some of these CNI configs are definitely node dependent if it's SRIOV or similar. So the hardware on that node. So there's a huge disconnect between the ability of designers, developers of CNFs to express their networking requirements and the actual implementation today in Kubernetes. So Multis handles the actual technical aspects of it perfectly. That's not something that needs to be replaced, but there has to be somewhere there in the middle that can take more abstract requirements and turn them into the very specific requirements for that cluster. So yeah, there are a few hands up here. So Ann, do you want to say something about it? Ann removed her hand. So Dim, please.
Oh, sorry, I was talking on mute.
Oh, okay.
Sorry. I think there's a pattern here between the what you call the POC plan, the bifurcated scheduler, and the inter-cluster network manager. There's a pattern that there are existing components or projects that can do the technical plumbing, but there's an intent policy level that's missing as they apply to telco. And I think that's what you're doing, right? Is that a correct read on it?
Yeah, I mean, to an extent, that's exactly, I understand the overall goal of Nephio is we want a declarative gloss over everything, right?
Mm-hmm.
There's an ideal, beautiful world where everything that we need is a custom resource or even an existing resource type. And you just put them all out in Kubernetes and the operators figure it out. They do what they need to do for each of them. Of course, some of these resources actually do speak to each other. There's an overall design.
Mm-hmm.
And that's kind of the environment that Red Hat is going to right now, right? If I showed you the previous slide. So yeah, that is the general idea, right? But the question, of course, is which resources go where
Mm-hmm.
and takes care of them. And but these are relatively small problems. That's why I really think at the end of
if I could
won't
just
have a lot of code.
interrupt for a second because we're starting to. I do want to preserve some time for it to go.
Yeah, I do too. So
Jim,
Thank you. No more question.
Okay, thank you. Yeah, so I'll finish very quickly. I know there are a lot of hands up, but yeah, we do need to get to John's presentation too. So I'll just mention one last component, and that is the device configurator, right, in the workload cluster. So this is the thing that speaks netconf or related protocols or other custom protocols for configuring devices. And we know this is necessary if we're working in the 3GPP world with netconf and Yang or GNMI or whatever it is. A very small point that I'll add at the end here, you notice that I put the adjacent Pnfs outside here. And the device configurator, I also imagine talking to those. I struggled quite a bit of how to put these into the diagram because there are Pnfs, and we know that we have system to manage them too. But what I mean by adjacent Pnfs is, I'm calling them adjacent because they're related to the CNF itself. It's not just Pnfs out there that are part of the network service, but the point is that for the CNF to function, it needs to configure them as well. So it could be a top-of-the-rack switch or similar. So the adjacent here is very important. The idea is it's not some arbitrary Pnf out there, but it's a friend of the CNF or requirement for it. So yeah, I see a lot of things in the chat about work being done in it. Actually, many of these things I'm familiar with. So I'm going to stop here. I know there's a lot of discussion to be had, and John, please take over, and we'll probably have to delay even more deep discussion to next session as well.
Yeah, probably. So Dim, I assume you wanted to talk about I think that sounds awesome, and we'd love to see that maybe a demo of that in a future meeting. But just in the interest of time, if it's okay, I'm going to just move on. That's definitely something we need. And I'll just say in this diagram tile, it's not that really different. I'm just focusing a little bit on a slightly different aspect and also trying to get something out the door in a few months. So looking a little bit at your diagram to start anyways, yeah, my blue box extends up into here. And I believe that it's kind of the same box. I mean, they're related boxes. So your planter thing sounds awesome. Sounds very in line with the other pieces that I want to do. What I would probably do, what my proposal would be a little bit different would be, it's going to be built a little bit on top of the infrastructure that, as Vim was saying, Captain Porch and some of this infrastructure is provided to sort of integrate it with the GitOps in a very direct way. And I believe we get certain advantages from that. And then, as I said, the inter-cluster networking and the network manager on the workload clusters, to some extent, are probably next version or future version. Okay,
sure,
awesome.
It's a good idea to have a view of the landscape, even if it's something future that.
Yeah, absolutely. And to go then to this, yeah, we have this from. I'll just, the equivalent diagram is probably, there's a couple of them. So this is back in the original launch, and it's very high level, like block diagram here. But so these blue pieces are quite similar to what you're talking about with Planter. And some of the green pieces are a little bit more what I'm talking about with Captain Porch, and there's a relationship between them. So just a sort of to give context. So that said, drilling into this document, I don't have quite as pretty, I don't have any diagram other than these old ones, but what I'm trying to get at here is actually, I'm trying to get down to an execution plan. So I'm trying to get to the point of, I had hoped to propose at the same time as this, but we'll do it by the end of the week, of like, here are the actual things we're going to deliver early November for our, because we have an actual workshop and demo in mid-November at the One Summit. And I want people to have something they can have their hands on and actually install and execute and run some software. So I'm trying to get to that level of detail here. It's not quite there in this document, but that's what I'm trying to get to. So what I'm really talking about are a few things. So there's the upstream components, which are the pieces that Tal had in orange for the most part on his diagram. And for me, the CI/CD is also upstream in a sense, but we integrate it with it a bit more tightly, I think, than Tal is with Planter potentially. The main functionality kind of Nephio, as I see it, is around the understanding of the particular telco workloads and how they relate to one another. So in that sense, I've sort of created a series of components here. The kind of three most critical are your infrastructure, CRDs, and controllers. So yes, we would be consuming these upstream. So these are your, the upstream pieces of those are things like ACK or cluster API. But Nephio's automation controllers. So the controllers, and this I think is sort of where Planter's fitting in a little bit, but there's going to be controllers that actually understand, could take an input such as, I want a very high level input of, I want a network across this geographical area. I have some sort of model that tells me by geography what my capacity requirements are. And then I can combine those two things together with sort of opinionated, packaged understanding of individual network components, network functions, and that resource and that controller can construct the network topology for me, and can meaning the network functions, where they should run, which ones should be connected to which. Obviously, there's no transport here, so that's another step. So we're assuming a certain transport architecture, but and can configure things like the capacity requirements, be they CPU, memory, network, whatever they may be, for each of those network functions based upon some modeling that's done to understand, for example, the terminology of the very high level of, I want to support this many UEs in this particular geography and this many across the entire core. And so the idea is that Nephio, the platform of Nephio provides the infrastructure to make this kind of thing possible, but the real brains of it are in those controllers that get written. So that's sort of the high level vision. What that boils down to when we start to break it down into individual components is, one, we need a mechanism by which to configure and represent, rather, those particular network functions. So we need well, first of all, the infrastructure components, which in this document are just sites and clusters. Obviously, there's more than that, but that I sort of defer into the externalize into the packages. So much in the way I think Tal was describing, Planter doesn't need to know the details of how you actuate a particular configuration at a low level. Same principle here. Nephio actually doesn't need to know that. A lot of those details get externalized into packages. So there's certain things that Nephio needs to understand about the automation of a particular thing. So, for example, in a relationship between an SMF and a UPF, it needs to understand that what those things are, how they would be distributed across a fleet of clusters, the kind of ratio of, like, if given a certain set of capacity requirements for UEs and maybe uplink and downlink of those UPFs, it needs to know how to configure each of those on either end of that connection. It needs to know that they're connected and configure like the connectivity between them. So those aspects, as I understand it, and like I said, I'm not a telco guy, so maybe I'm saying things that don't make sense, but as I understand it, these are the sort of things that the standards models actually deal in, right? They deal in identifying the particular network function, what its role is within the network, what function it provides, and which ones it needs to connect to and how. And so that's the kind of thing I want to put into what I call the 5G topology CRDs. So this is the resource that understands at a high level what a UPF is, what an SMF is, and how to distribute them across clusters, and how to connect them together. Then the details of it are externalized into bundles of configuration, which from the point of view of this controller are only present a narrow interface. And that narrow interface is common across all of the implementations of that UPF or SMF. So that common interface that it represents is effectively, we've talked in the past about the idea of packages advertising an API that they can be accessed by via, and that's what those are. And then these higher level controllers can access it. So what do we need concretely? We need a representation of the topology. We need a representation of each of the network functions. So we need a CRD, and there's a little bit more complex model there to make it sort of multi-vendor and sort of work in this abstracted way. We need controllers that operate purely at that level. Now, when you get down to the well, I don't want to go too off base. We need then so CRDs to represent each network function, potentially controllers to process those CRDs. We need topology CRDs that represent the relationships between those network functions and how they map down to the infrastructure. And in order to understand how they map down to the infrastructure, we need at least to be able to consume representations of that infrastructure. So that's what my infrastructure CRDs are. In the V1, we are not, as far as I know so far, actually talking about provisioning that infrastructure. So what we need is simply a representation of existing infrastructure. If we go back all the way to the POC I did, this is where I had this concept of cluster, and it's a Nephio concept of cluster. When a cluster is provisioned, in V1, we're provisioning out of band. So we can manually populate the Nephio management cluster with the information about that cluster. Eventually, we can add a synchronization process from the cloud or whatever inventory management system you have for those clusters. And that works when they're provisioned out of band. When they're provisioned in band, meaning by Nephio in a future version, you simply include that Nephio cluster in the package that also includes the cluster provider specific provisioning artifacts or resources. So CRDs for the functions, CRDs for the topology, and then these other pieces end up being future things around rollout, multi-cluster selection. So this is where Planter, I think, would potentially fit in. And of course, we need user interfaces and we need installation pieces. Yeah, Tal.
Are you thinking, there's a Nephio image of clusters, of course, but are you thinking of involving discovery in this too, right? There's quite a lot of product work out there done, and we have a site inventory, of course, but when nodes come up, they announce their own hardware capabilities, et cetera, to the network, right? So there's a kind of a dynamic back and forth. So do you imagine that some of these site custom resource, say, or a bunch of custom resources will come from another component that would discover and generate them for us?
Yeah, so I think we have that's what I meant by when they're provisioned out of band, they can be manually added, or there can be a controller that discovers them from a cloud provider API, from a CMDB, or any mechanism. The idea is the decoupling. The core idea is the decoupling. We have the resource. How that resource gets populated is actually, we're indifferent to that on the consumption side.
Great.
And when you get down to node level requirements and some things like node feature discovery, like that stuff needs to bubble up, but I'm not sure that it needs to bubble all the way. It may need to bubble eventually up to the management cluster for the purposes of placement. When we look at does this cluster support certain functionality, or what's the capacity left in this cluster when you're talking about the kind of things that Planter is talking about. Yeah, Avish.
Yeah, thanks for the explanation, John. I mean, this seems very consistent with what I had heard at the summit too. Like, when you're talking about network functions, just the configuration of that, and when you talked about the topology, and this is what when I'd been mentioning this a couple of times too, right? So earlier, when this gets applied to RAN workload, this was a question I posed to Kandan. In the case, if you have CUs and DUs, it seems like it will allow for you to bring up a CU and a DU on different clusters and configure them to be able to talk to each other. That is what my takeaway was back then, and it seems like that is what the value prop seems like for somebody like, hey, how is this going to work on the for the RAN workloads? But again, there are other things which I think you also tried to clarify in earlier conversations about you guys are going to try and use what is available open source solutions, the bare metal operator and all that stuff probably will come into play. So
right. No, that's a great point. So what happens is when you want to do RAN, you have another controller that I want to get to the point where so this questions has come up a few times around, and how much time do we have? Okay, I want to give Ravi a chance to talk to. These questions come up a lot of times around like, are we doing everything in CRD as an operators? And there was a question on, I think Eric brought up on the in the document. And I said this in the summit, and I'll say it here, like an operator that basically just takes a CRD and uses it to fill out a bunch of manifests and then apply it to the Kube API server is not adding value. It's adding constraints and complexity in development and deployment. And so that's not a valuable operator to me. To me, we have a toolbox. Our toolbox consists of things like kept packages, even Helm charts. I don't think they'll work for us in the long run. So that's why I don't think, because of a variety of reasons I'm not going to get into now. We have things like basic Kubernetes resources, which is what all kept packages are. And then we have things like CRDs and operators, which provide an opportunity for us to write code that has a deep understanding of something around that use case. And that's what CRDs and operators are good for. So the classic example is there's no Kubernetes resource primitive to say you need to quiesce a database before you back it up. You need to quiesce a volume in a database. You need to go run this command in MySQL or whatever it is before you back up that volume. An operator, though, can know how to do that. So it's adding functionality beyond basic Kubernetes primitives. If an operator doesn't add value beyond basic Kubernetes primitives, if all it does is spit out resources at the Kubernetes API, it's may as well do it in a Helm chart or a kept package, because then at least you have access to those manifests. You don't need to wait for the operator author to build a new version of the operator in order to make any tweaks. So this is an important point to me anyway. Ravi, yeah, we're just about out of time, so let's let you talk.
Yes, thanks, John. I haven't gone through the document. I'll go through it in more detail later. But because you're mentioning so many points in terms of basically evolving the CRDs so that you could relate the topology aspect, the location dependency aspects, interrelationship between network functions, and so on. So is there because you, at the end of the day, you want to kind of evolve the CRDs in certain comprehensive way. Is there a way you can represent it in some in some kind of a hierarchical diagram or UML kind of a diagram sort of thing, so that okay, this block depends on this, and these are the basic data that would be described. Something like that.
Somebody here who's here at Google, but he's starting to participate more in the community. He asked me the same question. I think it's right there. We need to define what they are, right? Like somewhere there's a comment in here, like, can I get a diagram that shows me this resource flow? Because the idea here to me is to provide the right resources make the right decisions in the right places and decouple. It's all about decoupling. It's about what resources make what decisions and what's the sort of input and output. So we have these topology resources, and their inputs are something like very high level, here's a geographical model of demand, here's overall throughput, and that's what I understand on the input. On the output, I understand I need clusters in these areas, and those clusters have to have these capabilities, and I need network functions running on those clusters with these levels of capacity. And even there, levels of capacity doesn't mean memory and CPU. So if there's I don't know the network functions well enough to give you an answer, but imagine that there's a network function whose primary sort of external capacity measurement is requests per second. It can handle a certain number of requests per second. As the topology controller, that's what I need to know about that, requests per second. I don't need to know what memory and CPU it needs. I can't know that. I need to say that only that package by that specific vendor can tell me that. So I need to be able to feed into that resource. I need this many requests per second. And I may need to be able to read back from it. Oh, then you need to build a cluster that can handle, give me 12 CPUs and 32 gigs of RAM and 7 replicas like that, right? Like we have to deal keep the separation of knowledge or understanding at the right layers. So I agree. A diagram would help a lot. I was really rushed to get this document out before the meeting, so I just didn't have time for that.
Sure,
So,
sure. Yeah.
John,
Thank you.
we have 1 minute left. I do want to be respectful of everybody's time. My suggestion is that we continue this topic next week. Vim also has a proposal he's working on, and I encourage other people to also read our proposals, of course, too. Don't start from scratch, and work on yours as well. I think that would be great to continue this, because we need to figure this out if we're going to have a 1.0 release, right?
Yeah, and well, I'm sort of moving forward with my resources here to make, because we gotta deliver something, and we'll evolve it over time. But I'm going to propose by the end of the week actual pieces of code we're going to deliver in the next few weeks. So I have to make progress.
Can people help? I mean, can we sorry, I raised my hand. Jump right in before we're running out of time. Can we identify some component like what you just said, John, and for example, Planter, that people who have time can start double clicking and diving in?
Yeah, I think that's what we're going to do over the next
a little
week.
gun ho. Sorry.
Yeah, we are at the top of the hour. That's a big question, and we'll put that on the agenda. So, John, how about this? The agenda for next week will not just be more presentations, but actual decisions. And the point is, yeah, even if they're temporary decisions, that's fine too, because we need to deliver something quickly. So we can put maybe a draft of, this is the current component list, and parallel to that, we're going to discuss, well, how will this component list evolve into something, right? As we said, some things might be better left for version 2.0 or something like that. We can, but yeah, we have immediate concerns. So yes, there is going to be a meeting next week. I think that's what we're agreeing on. Same time next week. We'll figure out how to update everything, and we'll continue today's topic. And the other items on the agenda for next week, I think they might be better off pushed forward again. We'll see. John, you and I can discuss the agenda after this.
Okay, sounds good.
Thanks, everybody. This was a little bit rushed. We had a lot to put in today, but we are trying to make progress, and I think a weekly cadence will really help. So that's great.
All right, thank you, everybody.
Thank you.
Thanks.
Thanks.
All right, bye.
Bye.
Bye.